In this video, we'll try and understand what are easterlies, westerlies, subtropical highs, and subpolar lows. Actually, this topic is part of class 11, chapter 10, atmospheric circulation and weather systems. Now, there's going to be a full video on that chapter, but in this video, I wanted to particularly discuss about atmospheric circulation and its patterns. And I believe it needs a separate video, so here we go. Now, there are these 2 months in a year that you need to specifically remember, January and July. Because during the month of January, the northern hemisphere has the ongoing winter season. And I think you can easily figure that out because in the month of December and January, it's winter and chilly. Now, what that means is the northern hemisphere of Earth is tilted away from the sun. And that makes the southern hemisphere exposed more towards the sun rays. Likewise, in the month of July, the northern hemisphere witnesses summer season. Now this time, the southern hemisphere of the Earth is tilted away from the sun, and that makes the northern hemisphere exposed more towards the sun rays. Now, whether it is January or July, one thing you must keep in mind is that near the equator, the sea level pressure is always low, and the area is known as equatorial low. And the reason behind that is, however the Earth moves or rotates, the equator receives insolation all throughout the year, and that makes the equatorial region warm throughout the year. And warm temperature makes the surrounding air warmer. As we know, warm air rise and that leads to a low pressure zone. Alright, remember this point. Okay, let's move from equatorial region to 30 degrees north and 30 degrees south. Now these two regions are called subtropical region. It's a tiny little place between tropical and temperate zone. Let me first tell you what this region is about and then I'll explain. So this region has a lot of high pressure areas. And that's how it is known as the subtropical highs. Okay, now let me explain why this region is called subtropical high. The reason behind that is Hadley's cell. To understand Hadley's cell, you will have to look at this illustration. The sun is the ultimate source of energy that drives the Earth's weather. Now this fact should be absolutely clear to you. Most of the energy of the sun reaches the equatorial region and the least energy reaches the poles. I'm talking about North and South Pole. Now, if there is a lot of insolation at the equatorial region, then obviously it will make that place warm. Similarly, North and South Pole is cold because minimum solar energy reached there. If I have to say this concept in some other way, then just remember this. As we go away from the equator towards the poles, temperature drops. I hope so far everything is clear and you are able to follow up. Now let's try to understand the atmospheric circulation pattern, because this is what redistributes heat on Earth and makes life possible. Alright, so moments back I told you that however the Earth moves or rotates, the equator receives insolation all throughout the year. And that makes the equatorial region warm throughout the year. And we know that warm air expands and rises. Now having said that, the warm air at the equatorial region rises and moves towards the poles. That's why you will find clouds and rain in the tropical region. And you will also find that tropical region is moist. Now the air rising near the equator goes up to a height of 10 to 15 kilometers above the surface and starts moving towards the poles. While going on its way to the poles, it comes down or sinks at the subtropical region. Now this pattern of atmospheric circulation is called Hadley's cell. It is named after George Hadley. He was a famous meteorologist who proposed this mechanism. Anyways, as the air moves towards the subtropics, it comes down over the oceans, and that creates a high pressure zone. Because you see, in the northern hemisphere, these high pressure systems are located over the North Pacific and North Atlantic Ocean. The famous Bermuda Triangle is also located at the North Atlantic Ocean, and that's a high pressure zone. So if anyone asks you the secret of Bermuda Triangle, this is the possible logical reason. So the air that moves from the equator towards subtropical region, that air is warm. And then you also have to understand that there is cold air that is flowing towards the low latitudes from poles. Because as I said, the atmospheric circulation redistributes the heat. That means cold and warm air keeps moving here and there. When cold air from the poles arrive towards the low latitude, and then we know that warm air from equatorial region moves towards the pole, what do you think will happen? Cold and warm air will collide, and they will collide at mid-latitude, that is the subtropical region. Always remember this point, when warm air meets cool air, that is when turbulence occurs. It's a highly unstable situation for pilots and aviation industry. The air will converge, meaning it will sink. Now, I want you to think for a while. When the warm air moves up at the equatorial region, it reaches the end of troposphere. Now, at the end of troposphere, you'll find thin layer of cool air, because always remember, air is warm at the bottom of the troposphere, that is near the ground level, and as the altitude increases, it gets colder. So this warm air has to deal with the cool air of the troposphere and the cool air from the poles. You see, it's a 2-on-1 situation. It makes it all the more easier for the warm air to sink over the subtropical region and become subtropical high. Because converging means sinking, and that's what creates a high pressure belt. Anyways, just keep in mind, warm air and cool air collides and sinks at the subtropical region, giving rise to subtropical high. Another important point to remember is, when air sinks and comes down closer to the surface, it again gets divided into two parts. One part of the wind heads back to the equator and the other goes towards the pole. Just keep this in mind, I'll get back on this in a while. Now let's go beyond subtropical high. In between 50 to 70 degree in the northern hemisphere and 50 to 70 degree in the southern hemisphere. This region also lies at the border of temperate and frigid zone. And it is a low pressure belt, okay, and that's how it is known as the subpolar low. Now think for a while. All this time we read that low pressure is supposed to develop due to warm air, because if you look at the equator, that region is warm and warm air rise, and that's how low pressure belt is created near the equator. But over here, it is supposed to be cold. I mean, from temperate zone, it starts getting colder. So how is it that this region is called as subpolar low? It sounds a little confusing, right? The straightforward logic of temperature and its relation to pressure doesn't seem to apply well over here, right? So what do you think could be the reason? Now let's go step by step and try to understand the logic. So the first thing that we are clear about is that the low pressure in this region is not caused by the temperature. And the second thing that you need to understand is that the low pressure belt is mainly found above the oceans, because the landmass, as we know, is cold, or in some places it's covered with snow and ice. Now if you remember, moments back we were talking about subtropical highs. We learned that it's a high pressure zone, and we also saw how it becomes a high pressure zone. You know, the warm air from the equatorial region, it rises and moves towards the subtropical region, and there it collides with the cold air coming from the poles. That makes the air sink over the Atlantic and Pacific Ocean, and that's how high pressure belt is created. That's the whole story. Now if you remember, I told you the air that sinks at the subtropical region, that forms the subtropical high. It gets divided into two parts. One part goes towards the equatorial region and the other part goes towards the poles. Now the same thing that happened in subtropical region happens here as well. The part of the wind that goes towards the poles collides with the wind coming from the poles. But the wind collides nearer to the surface. And let me tell you this, these are cold dry winds. When they collide and converge near the surface, they don't have any place to sink, so they rise. And when air rises, it is associated with clouds and precipitation. You see, it's creating a similar condition that exists in the skies of equatorial region. That's how it creates a low pressure zone, which is called as subpolar low. And if you remember the wind that went from equatorial region to subtropical region, the pattern of atmospheric circulation was called as Hadley cell. Over here, the name of the atmospheric circulation pattern is called as Ferrel cell. Again, the air that rises at the subpolar low, it gets divided into two parts. One goes towards the poles, like the extreme part of the poles, and the other goes towards subtropic. And that's how a chain or a loop is created, where the air keeps moving from equator to poles and vice versa. Always remember, equator has low pressure zone, subtropical region has high pressure zone, then comes the subpolar region with low pressure zone, and finally the poles that has high pressure zone. And all these pressure positions keeps changing with the movement of Earth on its axis, because that's what affects the sun's heating of the surface. For example, during January, when northern hemisphere is tilted away from the sun, that's when northern hemisphere has winter season. The Hadley cell moves towards the lower latitude of the northern hemisphere. Likewise, in the month of June or July, it is summer in the northern hemisphere. The Hadley cell shifts to higher latitudes of northern hemisphere. So with this, I hope you understood the atmospheric circulation and its patterns. Now let's quickly understand what are these westerlies and easterlies. Now before I begin explaining that, you need to understand that Coriolis force affects the velocity and direction of the wind to a great extent. So all that we have read till now, the creation of low pressure and high pressure zones, it's all due to the movement of air from one place to another. Basically, atmospheric circulation is the large scale movement of air which redistributes heat energy on the surface of Earth. So what is Coriolis force? We know that Earth spins in its own axis. That's how we witness day and night. Every day the sun rises in the east and sets in the west. That means the Earth is spinning on its axis from west to east. Since Earth is a sphere and wider at the equator, so the rotational velocity of Earth at the equator is more than what it is at higher latitudes. For example, at 30° north and south, the rotational velocity is less than what it is at 0° equator. Due to the rotational velocity of the Earth, winds get deflected. Now an easy example to understand the concept is, you must have taken a ride on this revolving circular platform in a playground or in some amusement park. Now two people sitting on the opposite end of this ride throw a ball at each other. You'll notice that the ball will change its direction. With this demonstration, you can easily understand that how wind on Earth gets deflected due to the rotational velocity of Earth. And this phenomena is known as Coriolis effect. Now coming to westerlies. If a moving object is going towards north or south from the equator, it will deflect towards east due to Coriolis force. So westerlies are prevailing winds that blow from west to east in between 30 to 60 degrees north and south. Similarly, if a moving object is going from north or south towards the equator, it will deflect towards west, and again due to Coriolis force. So easterlies are prevailing winds that blow from east to west in polar and tropical region. I hope this video was helpful and served its purpose. I'll make all the pictures and illustration available on the website. I'll put the link in the description, just have a look at it. Let me know your thoughts in the comments section. Thanks for watching, and I'll see you in the next one.